Hello friends, Eli Hibbett here with the Pwn Your Homework Physics Series podcast. If you're looking to prepare, review, or gain an added edge or point of view about topics in physics, then look no further. Tune in each week to unlock your understanding of the physical world surrounding us. And now let's dive right in. Alright, how is everybody feeling today? I am your host Eli Hibbett and welcome to this week's edition of the Pwn Your Homework Physics Series podcast. Hope everybody's doing well today. Happy October. We're beginning October. Fall here in Long Island is very beautiful. I hope wherever you are, it's just about the same. It's getting a little colder here, but we've been having a nice couple of days here weather-wise. So I'm feeling good. I hope you're feeling good. I hope you're doing well with whatever you're tackling. And I hope your life with physics is doing better. So without further ado, let's get into it. Today, our inspirational physics quote comes from Paul Dirac, sometimes called Pam Dirac. And what does he have to say? He says, "If you are receptive and humble, mathematics will lead you by the hand. Again and again, when I have been at a loss how to proceed, I have just had to wait until I have felt the mathematics lead me by the hand. It has led me along an unexpected path, a path where new vistas open up, a path leading to new territory, where one can set up a base of operations, from which one can survey the surroundings and plan future progress." So with these quotes, I have tried to generally not just regurgitate them in other words for people. I think that, the quote is good enough to kind of give you a little bit of inspiration. But with this one, I definitely feel very connected to it because a lot of times when you're learning things math-wise or physics-wise, it seems very unclear, and I feel like I'm kind of just floating around in this big lake of confusion, and I'm not really sure where to go. And then all of a sudden, you'll just have this moment where everything crystallizes, and it will just take you. You can see the solution open up, and then it's just a matter of writing it down, and the answer just comes into your head immediately, and it's just a matter of getting it out on paper as fast as you can. So if you feel confused, don't worry about it. Those crystallized moments feel so good, and I'm sure you've had a few already, and yeah, it's awesome. It's an awesome feeling, so I hope you've had a few yourself already. And the reason that I chose that quote is because I think it ties in quite nicely with our topic today, which is unit conversion, which will be like the real first kind of nitty-gritty math-driven topic that we've done so far. The other ones have been kind of, just to give you a little taste of what's going on in physics. And, Greek letters, powers of 10, units of measure, they're very important, but they don't, your hands aren't quite dirty yet. And this is kind of the start. I mean, you're going to get a couple of little particles on your fingers today, and hopefully we'll get deeper into it as we go on. So this will be, another step into the ocean. So with unit conversion, when you're looking at an equation, not only does the algebra have to balance out, if you've done algebra in the past, but the units also have to balance out. On one side, if you have joules, the other side you got to have joules. One side you got EV, the other side you got to have EV. Volts to volts, apples to apples, essentially. You got to make sure that you're comparing the same thing. If you're comparing distance, on one side you can't have feet and then have it equal something in meters. That's actually kind of an interesting story. That's why one of the first Mars rovers crashed, because one thing was trying to drive in metric system, I believe, and the other one was in American. And so it was coming in way too fast and it just crashed, and that was the end of it. So units and making sure that your unit conversions are done properly is very important. Things can crash on the way to Mars, believe me. So I will post a link to that little story in the show notes if you're interested at pwnyourhw.blogspot.com. Check it out. And so let's get off that tangent and get back to business. So the units have to even out, and sometimes, if you're measuring one thing in something simple like millimeters to meters, you just have to make sure that on one side you have meters, the other side you have meters. You can't be off by 10 to the third, because nothing's going to make sense, or you're going to expect much larger or smaller quantities than you think. And it can be something as easy as that, like just converting, millimeters to meters, multiply by 1,000, or divide by 1,000. But other times it can be a little more difficult. If you're converting, let's say, feet to meters, you have to use what's known as a conversion factor. You need to know how many feet are in a meter. And so what I've tried to do for a lot of different topics in physics is kind of just break it down and make a step-by-step that you can walk through and kind of create a life raft that you can cling to, because does get kind of confusing. And if you just start going through the steps and kind of make it very formal, okay, if I go through these steps, I will get to the answer. And you may get confused, or you may have parts that you don't know yet, but it'll at least start you on your way. So for unit conversion, these are the 8 steps. Step 1, identify your current unit set. Essentially, to start any journey, you need to know where you are. So we're going to say this is where we are, and then next we need to move to step 2, identify your final unit set. So we know where we are and we know where we want to go. Step 3, break any units into base units if necessary. A lot of times this won't be necessary, but take for example the Newton. The Newton can be broken down into kilogram times meter per second squared, or the joule can be kilogram times meter squared per second squared. And so sometimes you need to actually break these things down into base units to get the units to cancel out, or to see exactly what you need to convert. Because if you're going to convert, newtons to foot-pounds, there's a little bit more going on there. You need to break things down into base units. Step 4, identify conversion factors of all current units to all final units. So once you know where you are, you've broken everything apart, now you need to go find those conversion units. Google is a very great resource. You can actually just type in most things, kilogram to pound, meter to millimeter, meter to foot, miles to meters, miles to kilometers. There's a lot of great resources there. And then once you have all of those conversion factors that you need, step 5, write an expression as a sequence of conversion factors. This is probably the most confusing part, because what you have to do is write your conversion factor as a fraction, which has one side of the conversion factor in the numerator and one side of the conversion factor in the denominator. A little sub-example here. So if you want to convert meters to millimeters, you would say, let's say you have 2 meters and you want to know how many millimeters that is. You say 2 meters times 1,000 millimeters per meter. And the algebra kind of works out. You treat the units as algebraic quantities. So you cancel out the meter in the numerator with the meter in the denominator, and the only thing that you have left is your desired quantity, which is millimeters. So that's what I mean by writing an expression as a sequence of conversion factors. A lot of times you can have, 6 or 7 conversion factors that you're going to need to multiply by. So it can get a little long, but, just stick with it and you'll get to your answer. Step 6, cancel out all duplicate units and conversion factors. Like what I just said, you cancel out the numerators with the denominators. And then you complete all necessary multiplication and division. Essentially at this point, all you need to do is just multiply and divide the numbers that you have. And then box your answer. Step 8, you're done. One little footnote here, boxing your answer is very important. And I highly recommend it in all of your problems, because it lets the teacher or your professor know exactly what you think your answer is on this long sheet of paper, which may have a lot of scrap work on it. And sometimes, if they're reading through a big, wild mess of you're essentially thinking on paper, they may think something else other than what you think your final answer is the final answer, and mark it wrong. So if you box your answer, you let everybody know what you think the answer is. And I would do it for every problem that you do from now until forever. And your professor will also thank you. So, little tip. So I think the best way to kind of see these steps in action is to go through an example, as always. And if you know me, I like to cook. And so I thought sort of an easy question to cover, audibly, is how many teaspoons are in a quart? It's not too crazy of a problem, so hopefully you'll be able to follow it by just listening to what I'm saying. Although on the blog I will have a step-by-step that you can take a look at if you need more information. So step 1, identify your current unit set. Well, we know our current unit set is 1 quart. So step 2, identify our final unit set is teaspoons. So we are at 1 quart and we want to know how many teaspoons that equals. Step 3, break any units into base units if necessary. It's not really applicable for this problem. It's really for a lot more complex conversions. So step 4, identify conversion factors. So I went to Google and I asked how many teaspoons are in a pint. And it says 1 teaspoon is equal to 0.01041667 US pints. Approximately. I haven't gone on far enough. It actually might have to do a little rounding. And then I also know that there's 2 pints in a quart. That is very easy. So we have our 2 conversion factors. So step 5, write an expression as a sequence of conversion factors. We'll take our 1 quart. We'll multiply by 2 pints per quart. And that'll allow the quarts to cancel out. Then we can multiply again by 1 teaspoon per 0.01041667 pints. So the pints will cancel out. Step 6, cancel out the units. On paper, you'd see quart cancel with quart and pint cancel with pint. And we're left only with teaspoons. Now we're going to perform our multiplication and division. So we're going to essentially multiply by 2. 1 times 2 is 2. And then divide by 0.01041667. And we get our answer, which is 1 quart is equal to 191.9999 teaspoons. Or, as its defined value, of 192 teaspoons. So there's 192 teaspoons in a quart, in case you were wondering. If you go to our YouTube channel, which I'll link up on the blog again, I do a walkthrough of conversion of speed of light in meters per second to miles per hour. So if you want another example, you can check out there. I also have an app, Exploring Physics Units Conversion, which lists these 8 steps for you to check out, and I also walk through 4 different examples. I do a more complex one where we convert from ergs to joules, which involves that step 3 of breaking units into base units. And then I also do conversion from miles per hour to meters per second, and radians to degrees, stuff like that. And then I also have 10 more problems like that if you need further review. So check that out. Grab the app if you have an iPhone. Otherwise, unit conversion. Become very comfortable with it. Do a bunch of problems, because the more practice you are, the better you're going to be. A lot of times, they'll kind of throw that into a problem to confuse you, because it's not something that you've seen before. You got to convert into something that you're comfortable with before you can even do the problem. So it's just another little hurdle you got to jump over. And you're going to see it a lot in class, in problems, and definitely in lab. You're going to see how, your measuring devices are all going to measure in different units. You're going to have to convert into like units before you can do any real math or any real work during your lab experiments. So it's definitely critical. Anybody will tell you unit conversion is essential to being a good scientist. So check it out. Grab the app, check out the blog, and leave me a comment if you like what you see, like what you hear, and tweet me at 2718 Productions. And I think that's going to do it. So I hope that helped to solidify your understanding of unit conversion, and I hope that this podcast is keeping you fired up about physics. So until next time, keep pushing the envelope, guys. Take care.